This video will go over the change of state lab and everything that you should look for on your lab. As you watch the video, you should take notes on your lab and on your rough draft, and I should be able to go back and see your rough draft and see the notes that you've taken. You can then use those notes to make corrections to the final draft. So the first thing that you should do is look at the actual lab page and scroll through it. And the things that you should have filled out, you should have a hypothesis drawn on the graph part. You should have all of your data completed in the data table. If you're missing any of that, including any observations, make sure that you talk with your partners and get that filled in. The final piece that should be here in this lab is your Excel graph. Should be copy and pasted into the space on this page here. So once you copy and paste your graph from Excel into this page in OneNote, then you want to make sure that you follow these instructions highlighting the appropriate places on the graph. So the yellow highlighting would be when it's changing from a liquid to a solid. It should line up right here where it leveled off. The green part of the graph would be when it was heating most rapidly, which should be here when it was already a liquid, and you might also have a similar spike up at the beginning part as well, depending on how hot your water was. And then in blue, when it was changing from a solid to a liquid, it should have a brief leveling off period in between where the solid was heating and when the liquid was heating. And then in pink, when it was cooling most slowly, that should line up again with pretty much the same place of your graph where it was changing from a solid to a liquid. So your yellow and pink highlighting should be around the same place. Now for the rest of the lab, once you've checked that you have all of that stuff filled in and your graph there and it highlighted correctly, your discussion questions should have been typed into a separate Word document. So you are typing these into a document in Word, and then you are going to print those into a page in OneNote. So what you're going to want to do for that is create a rough draft page underneath the change of state lab. So I'm going to make a new page here. So underneath my change of state lab, I've created a page for my change of state rough draft and my change of state final draft. I might as well create this now because I'll need it to put my final draft into. So what you should be looking at is your change of state rough draft. That's where you want to print in your Word document where you answered the questions. Since I don't have answers to the questions, I'm just going to go look at the questions and make notes beside those. But where you want to be making notes is on your rough draft page where your answers are. So I'm going to go through each of these questions and talk about some things that should be mentioned in each of your responses. Here is your opportunity to take notes on your rough draft about things that need to be fixed. The more detailed your notes are, the more you can fix and improve your draft for your final version. So for the first question, you're describing essentially what your data is showing. So you're describing the shape of the graph, but the most important thing here is that you're referring to specific data. So you're referring to specific time periods and specific temperatures where that is happening. So your first part would just be to answer the first sentence, just a general statement of what's going on in the graph. So if we look at the graph, essentially it just goes up, comes back down, and levels off and continues to drop. So just one sentence about the general shape would be a good start. And then you want to back that up with some specifics about where that's occurring. So you might say something like from 100 seconds to 500 seconds, the temperature climbed from 28 degrees to 92 degrees. So giving those specific times, and specific temperatures where the graph is changing. And there really should be 6 different phases that you should be describing. We have the first phase where the temperature climbed as a solid. You have the phase where it was changing from a liquid to a solid. You have the phase where the temperature was climbing as a liquid. And you have the phase, the part of the graph where the temperature was dropping as a liquid once you removed it from the heat. You have a leveling off period, and then you have the graph starting to drop again. So giving specific times and temperatures for all 6 of those different stages of the graph would make up a good answer for this question. The next question asks you to talk about what's going on with the molecules of the wax as they move from their liquid phase to their solid phase. And this is something that we already know from what we've learned about different states of matter. In liquids, the molecules are moving around. They're still joined to each other. So they move, they're joined. In a solid state, they're locked in place. They can vibrate. So there's more energy here with the liquid phase where they can move around. And again, you want to be referring to specific time periods. So if you're talking about this increased energy when it's a liquid, you might say something like from 300 seconds to 500 seconds, the wax was a liquid, and the temperature climbed rapidly, which means the molecules were moving more and more quickly. So giving something like 300 to 500 seconds as a liquid, the more energy, which means the molecules move faster and faster. For the third question, we're looking specifically at that part of the graph that got highlighted in pink, which also happens to be the part of the graph that got highlighted in yellow, where your graph leveled off. If you look back at your notes, that leveling off period should correspond to the part where the wax was changing from a liquid back to a solid. So that was the liquid to solid transition, where it slowed down. And one thing that we know about going through phase changes is that we can't have wax that's a liquid below its freezing point. So if the temperature is going to continue to drop, all of the wax must be melted. So all wax must be must be frozen. We're going in the opposite way. All wax must freeze, must turn into a solid before the temperature can drop. So what that means is as we're cooling down here, we are going down, 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 down the graph. It was dropping really quickly, and it started to turn into a solid here. It wasn't able to continue to drop further as it did later on until all of the wax had turned into a solid. So this extended time period where it wasn't dropping was the time when it was turning from a liquid to a solid. That was the time that it took for all of the wax to make that transition. And based on what we know about molecules, what was occurring there was that was the time necessary for those molecules to lock themselves into place. For the fourth question, we're looking at, in our experiment, we removed the wax from the hot water bath pretty much as soon as it had turned to a liquid. We left it in there for another 100 seconds or so. The temperature rose, but we removed it, and then the temperature went back down because it was no longer in the hot water. And then it eventually started to level off as it went through that phase change and then continued to drop a little more. What question 4 is asking is what you think would have happened to the temperature if you had left it in the hot water bath for a few more minutes. So one thing to keep in mind about this is the boiling point of water, which is 100 degrees Celsius. And that should tell us that the highest temperature that we could have liquid water is 100 degrees Celsius. So that water that was boiling couldn't have been any hotter than 100 degrees Celsius. So what that tells us is that the wax that's sitting in that water also wouldn't be able to rise above that temperature, even if that's below the boiling point of wax. So we would need another way of heating up that wax further if we wanted it to go up even further. So we had that wax temperature that was shooting up really fast. Right, so it was going up. If we left it in the water, it would eventually level off at around 100 degrees Celsius. So we might have a graph that would go up really steeply and then level off at 100 degrees because we couldn't get any hotter than that, at least being in water, because liquid water can't get any hotter than that. So this is the boiling point of water, so that would be the maximum that it could get to. And then if we eventually removed it from the water, then it would probably drop in a similar sort of way. The last question is kind of up to you, but it's important that you go into detail. So you want to talk about, you worked as a group of 3 here. How did you divide up the responsibilities? Who was in charge of using Logger Pro? Who was in charge of recording observations? Did you divide that responsibilities evenly, or did someone do more of one section? And then talk about who did what parts well, and what did you learn from your partner, and what might you do better to be a better partner and help out your group more next time. So there's actually 4 separate questions here for you to answer, and those, as long as you go through and answer each of those questions, then you should be good for that one. And the final thing, this should also be in your Word document as well, is just the conclusion question. This doesn't even need to be a complete sentence, or it could really just be one sentence. What is the freezing and the melting point of wax? Which we already know from what we've learned about freezing and melting, that these should be the same. And when you look at your graph, you could go to your observations and see that. But the other place that you can look here on your graph where this would show up is both of those transitions are a point where the graph kind of leveled out a little bit. So this right about where the graph was leveling off should give you that. You don't need the exact temperature, but the approximate range within 5 degrees for your conclusion. So you should have notes now on your full rough draft. You can take notes about everything that we talked about. If there's things that are missing from yours, you should have a note that you need to add that into yours. And then you can go in and make those changes, and you'll print the final draft into the final draft page that you've made here in OneNote.